Okay, in this video I'm going to have a look at the PIMIDI sequencer functionality. I want to be able to take a sequence in ABC notation and have it play automatically. So let's have a look at what I put together first. So I made a change from the last set of videos. Instead of the keyboard being called sequencer, I just called it the player. And so I've got a new tab for sequencer. Let's see what it does. So I can load a sequence I've already created. So I'm going to do this OTR 1, and I can set up some parameters. Let's set it up to repeat, and we'll run it at 170 and play it. And we can do things like transpose. Change the speed. Stop it repeating, or play it again. I'll just stop it. I put a helper in here. You see that the sequence is stored in ABC notation. I put a little helper here to remember what ABC notation is, but I'll show you a link to more info about ABC notation, and we can have all sorts of sequences we can store like this. So let's try all around my hat, play that one. And so on. So let's have a look how I put this together. Before I go too far, you may be wondering why I'm using ABC notation, or even what it is. So ABC notation, I'll put a link down in the description, but it's a standard way of writing down music without having to use notes and staves and things like that. And the main reason I'm using it is AI programs like ChatGPT. It's usually one of the options is to output things in ABC notation, so I thought I'll just make it easier when I get to the part of trying to make making a AI type tune generator. But let's look at this manually at the moment. So I've gone into ChatGPT and I've just put in a little query here to make some music in the style of Mozart. So I'll run that. Okay, and here's the result. So let me copy that. So now I can use a utility like Easy ABC, and I can paste in the notes that ChatGPT created, and I can even play it. So let's zoom up the tempo a bit and try playing that. So it gives you an idea that from something that's really, you can just type into a keyboard, you can get tablature output, and I can also bring it into my sequencer to play it there. But it seems to be the most straightforward interface from something like a ChatGPT into a sequencer, which is what I want to do down the road. Not in this video, but probably in a video or two later I'll be able to automate all that. There's quite a bit on ABC notation out on the web. Here's one example. I'll put the link down in the description. Okay, getting back to the code I used to implement this. So we'll start at the web.py file. So this is the web interface to the web services running on the PIMIDI device. It has like Flask defined web services using microdot. And then the things it's calling to run a sequence is sequencer.py library. It can do various things. It can do things like copying ABC notation files down onto the PIMIDI disk. It can actually run a sequence. It can change parameters for making it go faster or slower, or transposing it. And the way it does that is the sequencer library, when it wants to run a sequence, it'll run a thing called player.py. So it's actually opening it as a new sub-process. I did this because to to handle multitasking and have the sequencer run independently of everything else and not get held up by anything going on in the main program, I decided to use the sort of the power of Linux, which it's running under on the PIMIDI, and just fire up another process, this player.py process. I still needed to control that player.py process, so I have a file called player.json, which I update with information about how many beats per second for tempo it should be running at, how much to transpose the sequence by when it's playing it, and some various other things telling it when to stop and things like that. So again, the sequencer library updates this player.json file in real time so that the player adjusts when I make changes. Player always plays a file called default ABC, so when I run a new sequence, I create this default ABC file. So when you saw me using the user interface, whatever was in the ABC sequence text gets copied down to default ABC for playing. Another library I put together here is this abcHelper, and you might see why there was a bit of a gap between this and the last video. I had to make quite a few things. So abcHelper is a little utility that takes an ABC file, a file in ABC format, and converts it into something that player.py can run easier. So really just a sequence of array values telling when to turn notes on and off. It gets a little bit more complicated than that, and I'll show you some of the code to show some of the changes I had to make. And then finally it calls out to pimidi-ui, which is the thing, the services and the functions to actually play MIDI notes on the MIDI synthesizer. So we've seen that before, but Player makes use of that to actually play the sequence, get the audio output. So let's have a look at some of the code. Mainly I'll just concentrate on the interesting bits. Again, all this code's up in GitHub. I'll put the link down below if you really want to see it, but I'll just go over some of the gotchas and some of the problems I had along the way to get this whole thing working. Okay, let's have a look at the web services being called. So I'm going to go over to the sequencer. And see, as soon as I get in there, it keeps checking whether a sequence is playing. That just allows it to set the play and the stop values. So we'll let that run. So I'm going to load a new sequence. I'm going to load the metronome sequence, which is really just a low C and then three more higher Cs to give a metronome sound. We'll put it in repeat to make it like a real metronome. Let's just reset this and let's try playing it. So we see the play. The play service was called. Now let's stop it. Now let's dig down into the play transaction. This is the one here. So and we see here that it's a post, and we got back a 200 OK. Let's look at the payload for the post, and this is where the play gets set up. So ABC default is what gets put into the ABC file. So it's low C and then three higher Cs to get a metronome type series in 4/4 times. The speed 120 bits per second. This PPQN is how much the time management gets cut up. So it's parts per quarter note. So we can actually get down to 62 parts per quarter note of resolution. Where the repeat is true, and you see we had the repeat turned on and the transpose value, and they'll fire off the play. So let's drop down through the various Python code to see how this actually got implemented. Let's first have a look at web.py to see what it does with the post transaction. So inside web.py, this is where all the web services are defined, and it's using fastAPI as my web service interface. I said microdot earlier, it should be fastAPI. So we see here, this is where the play web service is defined. So it's looking for a post. to sequence/play route, and it calls sequence play, and request, which is the post body, comes in with it. So we wait for the request body to come in, do some decoding and pull the JSON variables out of the body, goes into play info, and then I pull out each of the values that we're sending over the play info. So whether the repeat flag is set, the bits per second tempo, whether the transpose value, and also what came down was the ABC default file that's going to get played, and it's calling the sequence object. So up here you see where we imported the sequence class from the sequence library. So that's what it's using here. So we'll go down to the next level and have a look at what each of these sequence functions are doing. And then you see here the last one was sequence.play, so this is where it actually plays the sequence based on the information I passed here with the post. Now let's go down to the next layer, have a look what's happening down in the sequencer.py library. So let's have a look where we're setting the bits per second. So we're down in the sequence.py library, and we've set up the class. So one of the properties, so one of the setters for the class is this bits per second. So we were making bits per second equal to whatever value we sent down in the web service, and this is what happens down when it runs the bits per second setter. So bits per second gets passed. We pick up the player information, so everything that's in this player JSON file, just so we get a copy of it. We update the bits per second value property in the class, and then we write out the player information, which will be the bits per second plus anything else that we've got defined in the class. And so that results in a new player.json being written out. And similar sort of things happening with when we set the ABC default value for the sequencer class. The only thing that's different is it doesn't update the ABC default file. It just writes out a new version of it with whatever ABC notation string we're sending down to the sequencer. So you see it's writing out to sequencers default.abc with whatever was in ABC default. Then the last operation in the web service is to do the sequence class.play. Let's have a look at that. So basically it's just calling the play routine, which is just one line of code. So it's using subprocess to do a popen and using Python to call the player.py program. And so this runs, because it's running under Linux, it runs independently. So it runs as an independent thread and is not impacted by anything else happening on the processor. So now let's go have a look at player.py. So player.py is running independently on the architecture. You can see it's reading the default.abc, which is the sequence, and the player.json file, which is the parameters for running the sequence. And we'll also be using the abcHelper.py library. Let's have a look at what happens when the player program actually gets fired up. So if this is the player program here. So we enter the main routine. One thing I do is disable the garbage collection. Again, that can impact the timing that's happening. So because this runs as an independent program, I'm not too worried about it using up memory. So I just disable garbage collection, do some settings, and then the first thing I do here is get the player.json file contents, so that stuff there that we pass down to it, which are the parameters for when it's running, how it should run. And the other thing is open up the default ABC file, which has the ABC notation version of the sequence in it. Then I call abcHelper, which is another library here, abcHelper. We'll have a look at that in a sec. And its main task is to convert what the ABC notation, which is just text, into a series of actions that the code can use. And I put some print statements in here just so you can see what's happening. So let's try running the player.py and see these print statements here to see what it's done. So you see here it's showing you the bits per second, the PPQN, the parts per quarter note that it's using, is how much resolution it's getting for the timing. The bits per second, which is 120, where the repeating is turned on, and then the actual ABC notation sequence, which is a low C, two C's, a C 2 octaves down, and then 3 more C's, which just gives you sort of a metronome feel, where every quarter note it's going to play one of these C's. And then this one here is just going to go through what the abcHelper has done. So it's converted this text here into a series of actions that the program can use, and we'll look in a second what's happening with it. So it's separated into a series of actions. Each actions has a PPQN value. So again, remember we've got 64 parts per quarter note. So this is how we get our resolution. So if I wanted to do half a quarter note, instead of being 64, it'd be 32 as the next timing value. And again, these aren't specific timing values in seconds, because our beats per second is going to impact how it interprets these timing values. So if we have 60 beats per second, or 60 beats per minute, or 1 beat per second, and there's 64 PPQN values per beat or per quarter note, then the next quarter note will happen at 64. And then there's a series of actions that happened at that time. So usually the actions, or the only ones I'm really supporting, is note on and note off. So it's telling it to turn on note number 96 here. Sorry, it's 2 octaves above C with the PPN with the value there. So 96 is the MIDI value, turns the note on, and then at the next timing value it's going to turn off note number 96 and turn on note number 48, and then does that for the next 4 values, and then we have the final action of turning off the last remaining note, and then we'll drop back into here when we're repeating and start off again playing the 4 notes. So now things get a bit more complicated. So once we've got our abcHelper sequence as a series of actions, we want to play them through our MIDI interface. So to do that, I'm using Python timers. I'm actually using 2 that are set up as repeat timers. So a repeat timer is a timer that fires and then goes to sleep for X amount of time and then wakes up and runs again. And you create these repeat timers by wrapping the timer class, and you can see a link here to where I found this technique, but basically allows a timer to call itself to fire up again. So I create 2 repeat timers. One is this TPPQN, which is the main timer that is reading through the abcHelper sequence, what we see here, and firing out MIDI commands. And then this other timer is one that keeps retrieving the settings. So something I wanted to do was do things like change the beats per minute, or the transpose the sequence while the sequence is running. So this timer here in the background, so every 10th of a second it's going to open up and get running settings, which is basically opening up the JSON file and updating the settings based on that. So once that starts running, this is probably the bit to have a look at, this do ppqn. So this is what happens on each ppqn value, which is here, and basically it's reading through the sequence, keeps track of where it is in the sequence, and depending on whether it's a note on or a note off command, it does that. There's a special command called end that it looks for as well, so if it sees a end in that player JSON file, then that will cancel both the timers and return control to main. There's some calculations in here to be able to work out what the next timer value should be, or how long the timer should have a sleep until it wakes up next, and that's going to be based on what you see here, ppqn value and the bits per second, and the interval that we're trying to get to. It also modifies that time by time spent for doing setting the MIDI note, so it tries to keep the timing as accurate as possible, then runs through the loop again. So that's about it for the runner. So we'll have a look at this abcHelper and see how it does what it does. Let's have a look at the abcHelper class that converts that ABC notation text into a series of actions. So there's really not too much to see here. So abcHelper has a class, and then that class has a method called toSequence, and it reads through the characters in the text for the ABC notation, and does various things depending on what's in the text. Ignores a whole bunch of characters that I don't use for my notation conversion, and then basically does a case statement to drop through the other values to detect things like indicators that a note should be sharp or flat or natural. I don't support any keys other than C, so natural is not really needed. Whether a rest is required, the actual note value that's been requested, whether that note value should be increased by an octave or decreased by an octave, and then setting the note duration. So some of these characters here set up the duration, so it can be the quarter notes can be divided by 2 or 4 or 8 to get shorter notes. So this isn't really the full ABC notation interpretation you can do. They have a lot more complicated interpretation happening, but it works for me to put together some simple sequences anyway. And otherwise just writes out the array values of ppqn value, and then a series of actions to happen at that ppqn time. So that's about it for the sequencer functionality. Getting the timing right drove me a little crazy, as well as I was doing some other stuff between this, so that's why this one took so long. But have a couple more videos to do. I need to put together a way of setting the voices through MIDI, and that'll probably be the next video. And then after that, I'm going to have a look at interfacing to an AI system to have it automatically generate sequences that I can play, which is the whole reason for putting together this sequencer.